Up next, we're going to do a quick review of special right triangles from geometry. And the first one we'll look at is our 30, 60, 90 triangle, which I appear to be having some trouble with my mouse here. So bear with me. Okay, in the 30, 60, 90 triangle, you have two legs. You have this one and this one. Remember that the legs make the 90-degree angle. One's shorter, one's longer. So this one is the short leg, this is the longer leg, and this is still the hypotenuse because it's across from the 90 and it's like the ramp. You can make these, you can start with making these any length you want, but if you make the short leg 1, which is across from the 30-degree angle, the hypotenuse is always double that. So if that's 1, this is 2, and the longer leg is √3 times more than the short leg. So 1 times the square root of 3 is the square root of 3. So this relationship holds no matter how big or how small the 30, 60, 90 triangle is. So you have some facts about it. If you use 30 degrees as your reference angle, the sine is the opposite over hypotenuse. So if you start from here, you'd have opposite, which is 1, over hypotenuse, which is 2. That's where the 1/2 is coming from. But if you start at the 60 degrees as your reference angle, if you start here, your opposite would be the square root of 3, and your hypotenuse would be 2. So that's where that's coming from, and so on and so forth with cosine and tangent. Okay, so these are some references that you could use. The cosine from 30 degrees is √3 over 2. The cosine from 60 degrees is 1/2, so on and so forth. Now, the 45, 45, 90 triangle, that's half of a square. So your two legs are the same. Think of a square, and the hypotenuse is longer. So instead of a length of 1, the hypotenuse has a length of √2, which is about 1.4. Okay, it's more than 1. So again, you can use these relationships to figure out some values. So the sine of 45 degrees, if you start on either one of these 45 degrees as your reference point, and again, if sine means opposite over hypotenuse, from here the opposite would be 1, and the hypotenuse would be √2, so it's 1 over √2. You can do something called rationalize the denominator, where you multiply by top and bottom by √2. So 1 times √2 is √2, √2 times √2 is √4, which is just 2. So again, these are some facts. The cosine of 45 degrees is √2 over 2. The tangent of 45 degrees is 1, and so forth. So you can use this as a little bit of a reference sheet as we move forward. Example 2 asks us to find the value of x using the trigonometric functions that we know. So we're trying to find the value or the length of this hypotenuse. We're given a 45-degree angle, which is a big clue, and one of the legs is 13. So if you have 90 degrees and 45, that implies that the other angle is 45 because everything has to add up to 180. You may know that in a 45-45-degree triangle, both legs are the same. So if this is 13, this is also 13. And the hypotenuse is that number times an additional square root of 2. If you know that, that works. If not, you can use the reference sheet from the previous, like about 30 seconds ago, and you can do the following. You can say, okay, I need to find x, and I know 13, so if I use this as my reference angle, this would be the opposite, and this would be the hypotenuse. Opposite hypotenuse is sine. So I could say sine 45 degrees equals the opposite, which is 13, over the hypotenuse, which is x. Now I could make a substitution. On the previous slide, we saw that sine of 45 degrees is worth √2 over 2. So you have √2 over 2, that's a substitution, that's what it's worth, is equal to 13 over x. Now you can cross multiply. You can go √2 times x is √2x, and 13 times 2 is 26. To get x by itself, you divide both sides by the square root of 2. Those cancel, so you have x equals 26 over the square root of 2. If that's as far as you're comfortable taking it, that's okay. There's an old-fashioned rule in math that says it's basically like bad grammar to have a root or a square root in the denominator. So to undo that, you can multiply top and bottom by that denominator, the square root of 2. So now we have 26 times the square root of 2, which is 26 root 2, over square root of 2 times square root of 2 is square root of 4, which is just a whole 2. And then you can simplify it one better, because 26 divided by 2 is just 13. So your final answer is 13 root 2. Okay? Now, in this second part of example 2, now we have a 60-degree reference angle. So if that's 60 and that's 90, that only leaves us left with 30 degrees here. So again, you might know your way around a 30, 60, 90 triangle. This is the short leg here. This is the longer leg. This is the hypotenuse. Okay, the relationship between the short leg and hypotenuse is doubling or half, whichever way you go. So the hypotenuse is twice as big as this guy. So if this is 11, this is 5.5. Now, if that logic works for you, cool. If not, you can use the following. If this is our reference angle, this is the adjacent because it connects to the right angle. So I'm going to mark it adjacent. And this is the hypotenuse. So adjacent hypotenuse, that's cosine. So you can do cosine starting from 60 degrees equals adjacent over hypotenuse, which is x over 11. And now you can make a substitution. If you look back on the previous slide, the cosine of 60 degrees is always worth 1/2. So you can say 1/2 equals x over 11. Now you can cross multiply. 2 times x is 2x. Cross multiply. 1 times 11 is 11. Divide both sides by 2. And you get x equals 5.5, which is the same way we got by logic. So whatever way works for you, that's cool. These are just a couple of tactics in your arsenal. Now again, it is your turn to practice.